This online talk is based on a recently published report by the FSR Global team. And if you would like to follow this discussion also on Twitter, I invite you to follow us at FSR_energy and use the hashtags AskFSR and FSR Global to send us any questions on this report or other topics that you find interesting, and we will get to them even after the live event is over. Before we get started, I'd just like to bring your attention to the useful links and resources that you see next to the chat box. Feel free to download the full report or the policy brief, and we look forward to the discussion that will follow. With that said, Prad and Samson, please take it away with a brief introduction of yourselves and the report.
Hello everyone, I am Pradyumna. I work with the FSR Global team, and today we will talk about this report that we made over the last 1 year on charging infrastructure, charging up India's electric vehicles from an infrastructure deployment and power system integration perspective. Sam, would you like to add something?
Hello, I'm Samson and Hadush. I've also been working with Prad and Shweta and our advisors on the electric vehicles in India. I would like to welcome everyone. So Prad probably will start by telling us why EVs and why India.
They say that a picture says 1,000 words, but as you can see from this picture here, a picture says 1,000 parts per million. Some of you might have seen in the last couple of weeks, we have been facing a huge pollution problem in New Delhi, with parts per million reaching 2.5, reaching 1,000 parts per million. And that clearly shows one of the key policy drivers for EV, which is to counter air pollution and improve public health. Another one being how to reduce dependence on imported crude, as India is importing more than 80% of its crude from other countries. And then we have a very strong post-Paris Agreement emission goal that needs to be reached. And finally, there is a push from the central government to make India into a manufacturing hub for EV electric mobility. And then one of the key markets for global EV consumption would eventually be India with its 1.4 billion population. And what has India been doing about EV? So the debate and actually the first policy measures began almost a decade ago in 2010, when the Ministry of Renewable Energy gave a subsidy for electric mobility. And several steps have been taken over the years, right up to 2019, where the FAME 2 policy was implemented for electric mobility, and also very recently the Government of India guidelines that were published in late 2018 were updated in 2019. But what can we say about the evolution of the market? India still is at the introductory phase of the EV market development, with very few EVs and the charging infrastructure that really needs to be, which is still underdeveloped. So Sam, tell us more about what we did in this report.
Just one. I've unmuted you now.
All right. So so with this background and ongoing developments in the EV market in India, so how we framed our contribution in this report is by looking at the perspective of charging infrastructure, and another perspective being the power system perspective. So from the perspective of charging infrastructure, we looked at what policies and regulatory frameworks are in place to enable the deployment of this infrastructure. and also what business innovations, business model innovations are happening towards providing charging services. And from the power system perspective, they've looked at EVs as additional load that might need to be managed. And also, we looked at EVs as a potential source of flexibility through this vehicle to X. So by doing this through this framework, we try to what we aim to do is to frame and extend the debates on topics these four topics, and as well as like inform all relevant stakeholders on key aspects that needs to be factored in the EV development in India. So with that, I think probably you start by giving us a bit the insights that we have regarding the charging infrastructure policies and regulatory frameworks. What are Indian states doing?
So before we go into what the policy and regulatory issues in Indian states are, we would like to know from you what you think, how important is defining a charging infrastructure ecosystem for policy making. Jess, you have already launched the poll, so I request everyone to quickly choose your. Okay, two more. Last person. Okay, Jess, are you broadcasting the results?
The results now brought.
Okay, so I'm going to end the poll now. Sorry. Okay. All right. I would say the results are clear that it's extremely important, and although some people did say moderately important, but we see 90% with extremely important. Jess, can we go back to the slides? So I think I tend to also, and our report also tends to agree with the fact that EV charging infrastructure is extremely critical, and how you define the ecosystem would really lead to what sort of policy and what sort of regulation would be put into place. You can broadly define the ecosystem into four parts: the charging infrastructure itself, um, the consumer type, what sort of consumer you have, who are the key stakeholders that are to be targeted, and eventually what are the characteristics of an EV charging, of the EV charger or the vehicle that's being charged. So you could, for instance, in a consumer type have urban, within intra-urban, low-income, privately charged vehicles. So that policy would be completely different from if you go for an urban to rural, high-income, commercially charged infrastructure. And what we try to show here is the complexity that exists in defining the ecosystem, and how these constraints and priorities would later on govern the way policy and regulatory choices are made. Considering this background, then we can go on to the first part. What we did was we assessed the EV charging policies and the federal guidelines. So EV charging policies at the state level, we looked at 8 states and also the Government of India guidelines. And how did we assess it? We developed a framework. It looks at the EV charging from a supply side, which means the person who would really set up the charging infrastructure and provide charging services, and on the demand side, which is the user of the electric vehicle. Within each of these two dimensions, we had 6 sub-dimensions or elements which really focused, which went from fundamental market design right up to mandating utilization of V2X capabilities, and from technical standardization of charging for interoperability between different vehicles, right up to establishment of consumer complaint mechanisms on the demand side. And what did we see? You can see here the green shows harmonization or at least clear-cut definitions in some elements, while in several elements on the demand side, there is still much work to be done. The key recommendations that we had, and they can be spread over the three stages of market development: the introductory stage, the growth stage, and the maturity stage. Most of the supply side recommendations need to be concluded right at the introductory stage. That's what we think. For instance, payment methods. There has to be a wide range of payment methods. There has to be a clear definition of what sort of facilities would be available at the charging requirement. So you do not drive with a large car to a charging station when there is no parking available. And as you grow into the growth stage, you would need more clarity about what is the long-term role of distribution companies which are currently rolling out charging infrastructure, as India has an open market for charging, and then you would have a large incumbent having a lot of charging stations. So what is their role? And then finally, when you go into the mature stage, you will have to start thinking about electric vehicle as a service and V2X, which we will cover in the next part. So this is a quick overview of the sort of policy recommendations that we give on this topic. And then now Sam will talk a bit more about what businesses are.
Yes. So basically, like besides the regulatory and policy push toward charging infrastructure deployment, I think business model innovation is required also to really take it further. So before we look at the context, what kind of business models are today available in India and the international practices, I would like to know to what extent you think, I mean, in which stage of the market, EV market development, that you think business model innovation is important. So just let's launch it so you can cast your votes. Okay. Yeah, probably we could close the poll.
Results are broadcasted.
All right, okay. So we see the results are a bit spread. I've seen some of you voted for on maturity stage as well. But what we see is that this business model innovation is quite important at all stages in a way, right? And what we see in the context of India is that today the business models that we see in terms of charging infrastructure is that it is really focused on the essential services, really to provide the charging service, and it's limited to that. And these investments in charging infrastructure are being made by public service undertakings, energy utilities, as well as fleet operators, like Ola. So what we also see is that there are like limited, I mean, a few players today active in the Indian context, but more and more private players are also entering into this market. In terms of pricing strategy, what we see is that it's always pay as you go kind of pricing. So that's the dominant one. And normally these companies that are already active today, they are partnering with local authorities. So the focus in the current context in India is like really to kickstart the EV charging. And in terms of coverage, if we look at the cases that we've looked at, they are really focused on urban clusters. So really providing charging services in the urban clusters, meaning that it is like mainly for short and medium range mobilities. This is what we notice in the current Indian context. But if we look at international cases, as displayed in this slide, that we see a trend of business model innovation in three areas. So the first one is on service innovation. So meaning that they are going beyond like really providing the essential EV charging services to include additional services, like they are distinguishing themselves from other charging service providers by having like this green retailing and providing additional services like, say, for instance, multi-chargers, multi-charging facilities. It could be having IT application supports. It could also be like, allowing the EV driver to have multiple options, retailers being provided in one charging station. So these are like some additional services that are. And we see also in terms of partnership, as I said, in the current Indian context, partnerships are mainly with local authorities. But as the market evolves, what we see is the partnerships could also be different in that charging service provider, one charging service provider could partner with another one, get access to a wider network, or they could also partner with others to get specialized services. Say, for instance, it could be data analytics, smart contract, smart billing, this kind of service. So this is also another trend that we notice. And third one is that in terms of pricing, is going beyond this pay-as-you-go application or pricing strategy towards like charging subscriptions. This is like providing the EV user a preferential service, or it could also be e-roaming subscriptions, providing the EV user to a wider network of chargers. So these are like the three areas where we see innovation in markets where there are like the EV is in the growth stage. And these are like some inspirations that could be taken to context. So, and our recommendation basically is really, even if like the business model innovation is required at all stages of the market, and it should evolve as we go from introductory to growth and maturity stage. So the cases that we have seen today mainly, so some partnerships, some innovation could happen in the growth stage in the area of service provision and partnerships as well as pricing, right? So these are like some of the recommendations that we have in this regard. Right?
Okay, so with this, we come to the end of the first half. I see some questions, and I think Sam will answer the most recent one till I finish this frame. We finished the first two parts where we looked at policies and business models for charging infrastructure. And here we see that we have some things that have to be done now and some things very much in the future when the market really matures. But then there is another dimension to this interface. So there's one dimension which is the charging infrastructure, and the other is the EV. But we cannot be lost in the fact that EV is just a load, but it's a flexible mobile load which can move and which can become quite a handful for the system operator. But at the same time, it has a potential to provide flexibility. And flexibility in terms of vehicle to X, we had a question, what is vehicle to X? So vehicle to X goes beyond just providing services to the grid. It can also be services that are provided on the wholesale market with arbitrage or through vehicle to load, etc. So, and then finally providing frequency response and voltage control. But we will come to this in a bit. So before we go into that, Samson will talk about what sort of issues and what are the potential impacts of additional EVs as a load in the power system.
All right. Yeah. So yeah, indeed. So EVs can create some kind of unique kind of electrical load, which is often like quite mobile. It is their power dense and they're variable, right? So, and then this load is mostly connected at the distribution level. So because of these reasons, they need some special attention. That's what we say. And if we look at some studies doing forecasts about the future or like load that will be created by EVs, what we see is that it could be about 3% by 2030. EVs can contribute to about 3% of the total electricity consumption. So given this context, what do you think is the best option or way of managing this additional electric vehicle load? Is it to invest in additional generation and grid capacity to accommodate electric vehicles, or is it to provide price signals through time varying and locational varying tariffs? Or is it like that EV charging should be controlled by the distribution companies or third parties? Or you don't think that this is significant, that it needs to be managed? Okay.
The results are broadcasted.
Right. So I see most of you are like voting for time and locational varying types as a best option. I see also 3 votes on investing on additional capacity, also direct control by discoms. Okay, at least you don't think that there won't be any significant impact, right? So, but what we see is that most of these solutions are correct. And what the studies also show is that the additional, I mean, the contribution of EVs to the total electricity consumption, that could be easily accommodated. The problem comes when this consumption is like distributed over time. I mean, like it's not evenly distributed over time and location. So if all EVs are charging at the same time, there could be issues of peak demand. Can we go to the next slide? Yeah. So there could be issues of peak demand, or they could also create congestions in the distribution grid, right? So in this case, these two issues could arise if the EV load or the charging is not well managed. And one of the effects of this is like, okay, there could be at system level, your probably the total system cost could increase. There could be contributions to the grid aging, service interruptions, and so on. And the conventional solution, as some of you also voted for it, is that we invest on additional capacity to accommodate these peaks or to manage the conditions. These are kind of long-term solutions that require time, and at the same time, they might be expensive solutions, given that charging is not well distributed. So the alternative solutions to investments on grid or additional generation capacity is towards peak demand management. You could go for price signals to incentivize EV users to shift their load from peak hours to off-peak hours. In terms of congestions, we could also go for like the DSOs taking some kind of proactive measures to anticipate this the development of EVs, and also like so there are some emerging solutions that we will see in the next slide. So, and what we did in our study is to look at the different practices to provide price signals. And often what we see is these price signals are given in the energy part of component of the tariff, and as well as sometimes in the demand, which is quite rare. What we did is we checked how these practices are compatible with the current regulatory framework in India, and whether there are like technological enablers that are ready in India. So when you look at these price signals to incentivize peak demand, I mean to deal with peak demand issues, so a lot of states have introduced EV tariff, EV specific tariffs. But the design is quite varying in that only like about 4 states in, as you can see here, are providing price signals to EV users to shift their load from peak to off-peak hours. The rest are using flat tariff today. Even those which have applied the TOD, which is a time of day tariff, the price signal, the strength of the price signal is not that strong if we compare it to other cases. So the impact, one of the challenges is that it might not be strong to incentivize this shift. And on top of that, the technological readiness is another issue. Especially like if you want to apply this time of use or time of day tariff, you need to have at least smart meters, right? So the penetration of smart meters in India today is quite low. This it is often, especially like for residential consumers, it's not yet there. So this could be one of the big challenges to apply this price signals as alternatives. And if we look at the congestion management aspect, what we can see is that so we have like 3 options, right? So first is like we will go for proactive measures, which is to really incorporate EVs and charging infrastructure, I mean charging station locations in the grid planning and try to control the development of this. Or that the DSO or the DISCOM in this case publishes grid status information to guide investments by these EV charging service providers. So if you are like locating yourself in areas where the grid is quite congested, then it might be, like you have the information that there might be curtailments and so on. So that's one option. Another one is like really a theoretical option, which is to have congestion pricing, locational pricing at distribution level. So we have practices at transmission level in many countries, but at distribution level, we could have also locational pricing. And we know this is very theoretical and still at conceptual stage. So in the absence of these proactive measures and theoretical solutions, what we see today in some countries is that there are like solutions which are trying to manage congestion at the same time allow EV users or EV charging stations to connect to the grid. So one of these solutions is the variable capacity contracts. This is a non-firm connection. So whenever you are connected to the grid, you ask for connection. Normally you might have a firm connection, but in this case, what happens is that when you first connect to the grid, in your contract, it is indicated that you may not have firm connections depending on the congestions in the distribution. So this is a practice also that we see in offshore wind farms in some countries. And as the market matures, we could also consider like the DSOs procuring flexibility services, including from electric vehicles. So these are some of the aspects that we have looked at in this case. So I know if we look the different recommendations over the EV market development, what we see is like at this stage, especially today, what we recommend is like to take some kind of proactive measures to really anticipate the EV load and the charging infrastructure deployment in the power system planning. That the DSOs publish grid status data to guide siting decisions of charging infrastructure. And as the market grows and the enabling technologies are ready, we could also consider time varying tariffs and demand charges. We could have smart technology standards also as mandatory ones. We could also, because oftentimes what we have is like this technology, enabling technologies are expensive for especially end users, for residential consumers, that there might be some kind of business model innovation to be encouraged to make it more affordable, and also in terms of like making these price signals more effective and acceptable by consumers. So, and then in the maturity stage, we could consider flexibility. So this is how we track. I mean, like put the relevance of the different recommendations that we have across the EV market development. So, having said this, I would give the floor to Prad to give us some insights on the future, potential of EVs as flexibility services.
Thank you, Sam. But before we go into the next poll, I would like to take two questions here. One was from Gayatri, which said, "What would publishing of grid status information achieve?" So for that, my answer is this. There are two differentiations here. There is a social geography, and at the same time, there is a network geography. And who understands the network geography is the distribution company, while the businesses or a municipality understands the social geography. What do I mean by the social geography? I mean, where do you want these charging stations to be installed in terms of where the maximum use or the maximum profit can be made by a company. But for you to have a very efficient way of siting the charging stations, what you need to do is you need an overlap of the network topology, knowing where the constraints are in the network, and the social geography on top of that. And publishing the grid status information on one end could be a step from the distribution company's perspective to tell the companies out there who are giving charging infrastructure services where the problem lies. And after all, the second step of this whole process should be the distribution company and this private player sitting together, putting these maps transparently over one on top of the other, and then finding the most efficient places to set up these charging infrastructures. And to answer Alekia's question, regulatory bodies, and what we saw from the first part is that they need to really create a framework and a structure within which low entry barriers are provided so that more competition can in one way enter the market. There can be more innovation. The charging infrastructures are set up in such a way that everybody has access. And once the infrastructure is set up, we know that the chicken or the egg problem is no more, that electric vehicles are coming, you see it around the world, and we need to build this infrastructure. And that's where the regulation should come in to make sure that there is a way that this rollout of this infrastructure is enabled. So after answering these questions, I would like to open the poll, and here now we want to ask you, if you were a user of an EV service, what would be your priority? Would it be at the time at which you want to use the car, morning, evening, afternoon, middle of the night, or the distance that you would like to travel? Or would it be the money that you might earn from not using your car but plugging it in to provide some sort of vehicle to grid or vehicle to household service?
The results are broadcasted.
Yes, we purposely didn't, and we purposely didn't have all of the above option because we wanted to force you to choose one. I see it's very interesting to see that range anxiety is a main issue here, which is of course something well spoken about from the transport perspective. But it's good. It's interesting to see that that there is also some interest in the incomes and savings from V2X service provision. So, Jess, can we go back to the slides? So while doing the assessment about what sort of vehicle to X services, so I already mentioned to you these can be of different types, from vehicle to house vehicle, which means providing your EVs for personal use as a backup to your house, right up to grid services such as frequency response and voltage. But the most important thing here to understand is that EVs, the primary focus of an EV is to provide mobility, which brings with it some constraints, because if you have to provide V2X, you have to be connected to the grid at that moment. So there are two types of constraints that we identified. One would be the range constraint. So in context of providing V2X services, but not just the broader range constraint of driving the EV. So you have to be, if you have to provide, for instance, a voltage service, you have to be very close to the place where you have to provide it. So that would limit the distances that you can travel in that car. And the second being a time constraint, at what time of the day you can use the vehicle. So if you have promised to provide a service at a particular point, you will not be able to use your vehicle for mobility at that moment of time in the day, be it 9 o'clock in the morning or 2 in the afternoon or 5 in the night. And then we look at from there, we looked at how can these constraints, and okay, this is a bit forward looking futuristic, that when we have V2X as a service and we would have a market for it, but there is something that needs to be thought about today because the future is coming very soon. And then we looked at what sort of market design parameters that you need to have and how that would help in reducing these constraints. For instance, you can have smaller volumes that people can bid. The contract period, which is the time for which this bid is made, can be smaller. The lead time, which is the time from the moment the service is offered and when it's actually provided, can be short. Whether asymmetric products, for instance, upward or downward balancing should helps. And then finally, the most importantly, aggregation. As you can see, that aggregation has a yes for everything, because it leads to a much better predictive capability and thus appealing to all service attributes. So what were our key conclusions for the V2X part? Most importantly, that it will all happen at the maturity stage. At a technology level, we would really need to roll out smart chargers, chargers that can really enable the participation of these distributed resources. And from a regulatory market design perspective, aggregation is key. Allowing aggregation, enabling aggregation, creating a business case for them. Smaller package size in terms of minimum volumes and contract periods, of course, will reduce risk and uncertainty for provision of the service, even if it's an individual EV. The same goes for shorter lead times, and finally, allowing of asymmetric products will really give the choice to the what you can call the consumer or the EV user, whether it wants to provide an upward service by discharging the battery that it has, or by charging, or downward by charging the battery. Okay, to answer Carl's question, what do we, how do we define aggregation? We define aggregation as a single service provider which would which would participate on behalf of a larger distributed fleet of vehicles on the market of service provision. And asymmetric product, I think I just answered it. When I mean asymmetric product, this is more to do with provision of frequency response, where you can provide either upward frequency or downward response. So an asymmetric product is where you allow two different products which can be upward and downward, and not a single symmetric product where you just say that we will go both ways at one price. So with that, we have 5 more minutes. Before I end, I would like to summarize quickly and say that there are a lot of recommendations that we provide, but they would kick in at different parts of the stage, different growth, different parts of the market growth stages. So that at the introductory stage we have a few, then later as growth stage and maturity stage, and policymakers really need to keep all this in mind as we go towards a much more electric vehicle based future. And thank you everyone for being here. If you want to connect with us, we have here our LinkedIn, social media, Instagram, everything. You can contact Sam or me anytime. Our email addresses are available. We would like to, most importantly, like to thank our other co-authors, Shweta, and our advisors, Pablo Frias, Thomas Gomez, Jean-Michel Grachand, and also Yannick Perez, who's actually present here as one of the participants, and really happy to have him for their for a very deep and insightful discussions during the development of this report. Thank you. Sam, do you want to say something, and then we can go to a couple of more questions?
Yeah, probably we go directly to the questions. I have noted from Gayatri, I think. Sorry if I pronounce it wrong. So, what publishing grid status data, information would do? Is a question. So, this is basically what we are saying here is like it is mainly to guide the investors in charging infrastructure. So if there are areas where there is like frequent congestions happening and so on, so what this information could give to these investors is like, okay, maybe this is not the best area to site the charging infrastructure. So probably they could move to better connections. And normally, like, okay, if it is a structural congestion, then you might expect that to be reinforced and so on. But this takes time, so unless there are like this variable capacity contracts options and so on, this could be used as a starting point to guide siting decisions for charging structure. That's one question, yeah. The rest are explanations, right? So by flexibility services, what we meant was like only referring to congestion. In our case, we were referring to congestion management services.
To answer Siddharth's question, do you believe regulatory frameworks for EV passenger vehicle goods and fleets? Yes, regulators and policymakers have to be aware about the fact that these are different categories, and then you need to really focus and have focused regulatory frames and regulations for addressing the very typical issues that you might have for goods of, or like for buses and fleets as compared to a private Tesla that somebody owns. And that also really shows the importance of defining the ecosystem and defining what really you're creating a policy for. A good example of that is the buses which are in different, which can be charged at stations or not, and or to the small e-rickshaws which may even today go from plug-in charging to more of battery swapping. Who knows, depending upon the business case that exists.
Yeah. And Nicolo, also we have these charging subscriptions. So basically this could be like, a fixed amount that you pay to get this preferential service. Otherwise, there could also be a possibility to have like, okay, to a certain level of charging, you could accommodate it with the subscription, but if you exceed that level of charging, then there might be that you could be charged. There could be a variable part in the subscription model as well. So it's not really always just a fixed amount that you have to.
I think we are already out of time. Jess,
thank you for joining us today for this online talk. As mentioned in the chat, if you would like the recording and the slides, you can subscribe to our newsletter. And we welcome you to keep the conversation going by writing us at FSR_energy on Twitter and using the hashtag AskFSR to ask any questions that you still may have left over after this 45 minutes. And then, of course, you can download the reports, Charging Up India's Electric Vehicles, and others on our website. So thank you for joining us, and we'll see you next time. Thank you, Prad. Thank you, Samson.